Welcome students. In previous class we studied about the zeros of polynomial. Means for a polynomial with one variable for which value of the variable the value of the polynomial is 0. Now we will discuss some more things about polynomial. Here it is a remainder theorem. In this part, we will study division of a polynomial by another polynomial of less degree and comparing the value of polynomial at certain value of variable and the remainder in case of the division. And next we will learn the remainder theorem. First of all, as this is the case of division, let's take a simple division. Divide 44 by 6. Here 44 is the dividend and 6 is the divisor. So 44 divide by 6. Here dividend is 44 and divisor is 6. So if we here the quotient will be 7 and we will get 42, and from this we have the remainder as 2. Clearly 44 is more than 6 or 6 is less than 44. So divisor is less than the dividend. In this case, the quotient is 7. 7 is again less than the dividend. Now the remainder is 2, which is less than divisor. Now from this, what do we get? We can express 44 in terms of 6 as 6 into 7 plus 2. In this case, we can generalize it as dividend is equal to divisor into quotient plus remainder. Now let's see, if in place of 44 we take 42, then it becomes 6 into 7. 6 is the divisor and 7 is the quotient, and the remainder is 0. If the remainder is 0, then we say that 42 is multiple of 6 and 7. So 6 and 7 are also named as the factors of 42. So in this case, in case of number, we follow certain rule. Similarly, we have to, how can we divide a polynomial with another polynomial? Let's start with a polynomial divided by a monomial, say x. Now in this case, so here the polynomial is 2x cube plus 3x square plus x. This is to be divided by x. By distribution property or distributive property, we can write 2x cube by x plus 3x square by x plus x by x. This shows 2x cube by x gives 2x square and 3x square by x gives 3x plus 1. So we can write 2x cube plus 3x square plus x as x into 2x square plus 3x plus 1. In this case, x is a factor of 2x cube plus 3x square plus x, and 2x cube plus 3x square plus x is called multiple of x and 2x square plus 3x plus 1, and in vice versa, x and 2x square plus 3x plus 1 are factors of 2x cube plus 3x square plus x. Let's consider another division, that is 2x cube plus 3x square plus 1 by x. What happens in that case? Here, if we divide by x, then the first term is divisible by x. It is clearly seen. 3x square is also can be divided by x, but is 1 divisible by x? No, it is not. So we cannot write in this way. So what to do? In this case, 2x cube plus 3x square plus 1 is the dividend, x is the divisor, 2x square plus 3x is the quotient, and 1 is the remainder. So 2x cube plus 3x square plus 1 is not a multiple of x, as we have a remainder 1. Then we can divide a polynomial with another polynomial of less degree. Let's divide it. The question is 2x cube minus 3x square plus x plus 1, and this is to be divided by x minus 1. Let's understand the process of division in polynomial. Whenever something is given, the polynomial is given, first of all, we have to write them in standard form. What is standard form of writing a polynomial? Standard form of writing a polynomial is to write the polynomial descending order of the exponent of the variables. Here it is already written, it is already in standard form, so we can start with. Now for this, identify the first term of the dividend and the first term of the divisor. To get the first term of the quotient, we have to divide this first term of the dividend by first term of the divisor. Clearly it is seen that it is 2x square. So the first first term of the quotient will be 2x square. So it is written 2x square. Now this 2x square is to be multiplied with each term of the divisor and to be written below the dividend. So 2x square into x gives 2x cube, and 2x square into minus 1 gives minus 2x square. Now see, then we have to subtract. To subtract, change the sign. Now 2x cube minus 2x cube is 0, minus 3x square plus 2x square gives minus x square. What remains in the dividend? We have x plus 1. Now to find the second term of the coefficient, we have to consider this remainder as the dividend, new dividend. So to get the second term, consider this first term of the new dividend. So we have to divide minus x square by the first term of the divisor, that is x, that gives minus x. So we can write minus x here in quotient. So minus x into x gives minus x square. Minus x into minus 1 gives plus x. Now subtract. To subtract, we have to change the sign. So minus x square plus x square becomes 0, plus x minus x becomes 0, and the rest is to be written here. Now see, x minus 1 is the divisor, and what is its degree? Its degree is 1. And in case of remainder, we have 1 and its degree is 0. So in this case, we can write 2x cube minus 3x square plus x plus 1 is equal to our divisor x minus 1 into quotient 2x square minus x plus remainder 1. So here, as you understand, dividend is 2x cube minus 3x square plus x plus 1 is of degree 3. And divisor is x minus 1 and quotient is 2x square minus x. And in this case, as you see, let's try to understand their degrees. The degree of the dividend is more than that of divisor and the quotient, and the degree of the divisor is more than that of the remainder. So we can write the degree of divisor and quotient are less than the degree of dividend, and degree of remainder must be less than the degree of divisor. So let's generalize it. Dividend is equal to divisor into quotient plus remainder. If we can now summarize it like this: if px and gx are two polynomials such that the degree of px is greater than or equal to degree of gx and gx is not equal to 0, then we can find polynomials qx and rx such that px is equal to gx into qx plus rx. Just compare this statement with the things written in the headline, that is dividend is equal to divisor into quotient plus remainder. Here Rx means the remainder, the degree of remainder is 0 or less than Gx. Now come to this multiplication again. Here, what is the 0 of divisor polynomial? Which is the divisor polynomial here? The divisor is x minus 1 and its 0 is how much? Let's consider the divisor polynomial is x minus 1. So, to find the 0 of it, we have to solve this equation. From this, we get x equal to 1. Now, as we know, the 0 of this polynomial is 1. Let's evaluate the given dividend in terms of or for the value of x at 1. So, px as given is equal to 2x cube minus 3x square plus x plus 1. So P1 becomes 2 into 1 cube minus 3 into 1 square plus 1 plus 1. So what do we get? From this calculation, we get 2 minus 3 plus 1 is 2. That means the value is 1. Just compare the remainder of the given statement or the division. In the first line, it is written the remainder is 1. Now, the value of the polynomial at x equal to 1 gives 1. So, can we get some idea about this value of the polynomial and the remainder? Let's see. P1 is equal to remainder of the above division. So, from this we get the remainder theorem. What this remainder theorem states? It states, let Px be any polynomial of degree greater than or equal to 1, and a is any real number if Px is divided by the linear polynomial x minus a, then the remainder is Pa. Just see in this screen, you can see whatever is given there, 2x cube minus 3x square plus x plus 1. This is a polynomial of degree more than 1, and here 1 is a real number, and when it is divided by x minus 1, it gives remainder 1, which is same as the polynomial value at 1. Now let's know how to prove this theorem. Let Px be any polynomial of degree greater than or equal to 1, as it is the first statement of our theorem. And a is the real number and x minus a is a linear polynomial. So if Px is divided by x minus a, then we must have some quotient, and let it be qx, and the remainder may be say rx. So in that case, we can write Px is equal to x minus a into qx plus rx. X minus a is a linear polynomial and its degree is 1, and we know that the degree of remainder polynomial must be less than that of the divisor. So the degree of Rx is less than that x minus a. That means it is less than 1. So the degree of Rx is 0. And you already we have discussed that the polynomial of degree 0 are constants. So Rx is a constant here, and let it be R. Then if we put the value of x as a, what do we get? We get Pa is equal to a minus a. That means in place of x we write a. So we get a minus a into qa plus r. Clearly it is visible that a minus a is 0. So Pa is equal to r. What is r? R is the remainder. So this proves that if r is the remainder, then Pa gives the remainder. Now let's see some questions. find the remainder when x cube plus x square minus 2x plus 1 is divided by x minus 1. How to find this without division? Here it is, x cube plus x square minus 2x plus 1. Our px is this. And what is the degree? Degree of px is greater than 1. Now see, we have to divide it by x minus 1. So divisor is x minus 1. If we compare this, our a is equal to 1. So in that case, PA is the remainder. So what is PA here? That means P1 is equal to 1 to the power 3 plus 1 square minus 2 into 1 plus 1, and this is equal to 1 plus 1 minus 2 plus 1. 1 plus 1 minus 2, 0. So the result is 1. So the remainder is 1. Now let's see another question. So that the x cube plus 1 is a multiple of x plus 1 without division. How to show that a polynomial is multiple of another polynomial? That means if we divide it x cube plus 1 by x plus 1, if the remainder will be 0, then we can say that x cube plus 1 is a multiple of x plus 1. So our px is x plus x cube plus 1. What is our divisor? Divisor is x plus 1. Then what is a? To get a, we have to find x plus 1 equal to 0. That gives x equal to minus 1. So this is our a. We have to find PA, means P polynomial value at minus 1. Polynomial value at minus 1. So what gives P into, that is minus 1 to the power 3 plus 1. This gives minus 1 plus 1, which is equal to 0. Now see, we get PA equal to 0. So if the division would be there, then the remainder would be 0. Now in this division, if the remainder is 0, we can say that x cube plus 1 is a multiple of that of x plus 1. Now in these cases, as we saw that the polynomials are without division, we can find the remainder. Let's verify the second one. Dividend is x cube plus 1 and divisor is x plus 1. Dividend is x cube plus 1 and divisor is x plus 1. Now let's see, the first term of the dividend is x cube and first term of the divisor is x. So to get the first term of the quotient, we have to divide x cube by x, that gives x square. So we can write here the first term of the quotient. Multiply this x square with x gives x cube. Multiply this x square with 1, that gives plus x square. Now subtract it. To subtract, we have to change the sign. So x cube minus x cube gives 0, and here we have minus x square. And we have to write the rest part of the dividend, that is plus 1. Here the new dividend is minus x square plus 1. How to get the second term of the quotient? To get the second term of the quotient, we have to divide the first term of the new dividend by the first term of the divisor. That means minus x square by x, and this gives minus x. So our second term of the quotient is minus x. So we can write here as minus x. So minus x into x plus 1. Minus x into x gives minus x, and minus x into plus 1 gives minus x. Now again we have to subtract it. If we subtract, then change the sign. That is, minus sign becomes plus sign here, and here also minus sign becomes plus. Now we have minus x square plus x square, that is 0, and plus x plus 1. Now see, to get the third term of the quotient, we can divide the new dividend x plus 1, the first term of the new dividend x plus 1, with the first term of the divisor, that is x by x, that gives 1. So the third term of the quotient is 1. Multiply this 1 with x plus 1 will give x plus 1. Now subtract. If we subtract it, then what do we get? X minus x 0 plus 1 minus 1 is 0. Earlier we got the remainder as 0 using the remainder theorem. So in that case, x plus 1 and x cube plus 1, what is their relationship? X cube plus 1 is factor of x cube plus 1, and x cube plus 1 is multiple of x plus 1. Dear students, today we learn about the remainder theorem and how to use remainder theorem to find the remainder of a division by remainder theorem. So very easily, without doing proper division, we can find the remainder in this case. So this is the lesson today. Thank you.